The universe is expanding. We've known that for nearly a century. Galaxies are racing away from one another as space itself stretches in all directions. But what if something strange is pulling parts of our universe in one specific direction? Not just drifting, not just expanding, accelerating towards something vast, invisible, and unknown. Welcome to the mystery of the dark flow, one of the most puzzling and controversial observations in cosmology. In this episode of Infinity Beyond, we explore a cosmic anomaly that defies our models and hints at something beyond the edge of the visible universe. The cosmic microwave background, our map of the early universe. In 1965, scientists discovered the cosmic microwave background, CMB, the faint afterglow of the Big Bang still echoing through space. This ancient light is remarkably uniform, but it contains subtle fluctuations, tiny temperature differences that reveal how matter was distributed in the early universe. Think of the CMB as a cosmic baby picture, showing us what the universe looked like just 380,000 years after it began. We use it to study the shape, composition, and motion of everything in the cosmos. But in 2008, a strange asymmetry appeared in the data, something that couldn't be explained by ordinary expansion. It looked like hundreds of galaxy clusters were all moving in the same direction, and they were moving fast. What is dark flow? Dark flow is the name given to this mysterious motion of galaxy clusters toward a specific region of the sky. Measurements from NASA's WMAP and later the Planck spacecraft showed that these clusters were moving at over 1,000 kilometers per second, and in a coherent direction. This isn't ordinary cosmic expansion, which is uniform in all directions. This is a drift, like a current in the fabric of space, pulling matter towards some unseen attractor. The cause? Unknown. Some scientists believe this could be a false signal or an artifact of how the data is analyzed. But others suggest something more profound, that the universe we observe is only a small part of a much larger structure, and something outside our cosmic horizon is tugging on us. What could be pulling us? If the dark flow is real, it suggests the influence of something beyond the observable universe. Here are some leading ideas. A giant supervoid or supercluster. An extremely massive structure, far bigger than anything we've seen, could be exerting gravitational pull from beyond our sight. A remnant of the pre-Big Bang cosmos. If the Big Bang was not the beginning, but a transition, there might be remnants of a previous universe affecting ours. A parallel universe. Some multiverse theories propose that other universes exist near ours, separated by a thin boundary. One of these might be gravitationally interacting with our own. Anisotropies in the geometry of space, as space-time itself might not be perfectly smooth or uniform. Large-scale warps could produce directional flows of matter. These ideas are speculative, but they arise from trying to explain what we see in the data. Challenges and controversy. The dark flow hypothesis is highly controversial. Some scientists argue that the data from the WMAP and Planck missions is inconclusive, or that the signal might be statistical noise. Others have failed to replicate the findings with different methods. The debate continues, but what makes the dark flow so compelling is this. Even if the signal is weak, its implications are massive. If confirmed, it would mean that the universe isn't isotropic, that there's a preferred direction in space, and that would shake the foundations of modern cosmology. Observable universe versus actual universe. Let's remember, the observable universe is limited by the speed of light and the age of the cosmos. We can only see objects whose light has had time to reach us, about 46 billion light-years in any direction. But beyond that, the universe may continue indefinitely, and anything beyond our horizon is invisible to us, unless it exerts a force we can detect. The dark flow might be our first clue that the universe is part of something far bigger. What if it's true? If dark flow is real, we'd be facing a cosmic current, one that originates from outside our known universe. That would mean the Big Bang wasn't a local event, but part of a larger cosmic landscape. It could mean the existence of structures bigger than the observable universe, evidence of multiversal interaction, or even a violation of cosmic uniformity, something we've assumed for decades. In other words, dark flow could be a cosmic fingerprint from beyond the veil. What comes next? Future missions, with more sensitive instruments, may help confirm or disprove the existence of dark flow. Projects like CMBS-4 or the Simons Observatory aim to map the microwave background with unprecedented precision. We may discover that dark flow was a mirage, a statistical anomaly. Or we may open the door to a new chapter in cosmology, one where the universe isn't a lonely island, but one of many in a vast cosmic ocean. Final thought. The dark flow is more than just a direction. It's a mystery that points beyond what we can see. It challenges our assumptions. It invites us to think bigger, to consider that the universe we know is just a glimpse of something greater. Here on Infinity Beyond, we follow those currents, not just where they lead, but to what they represent. Because in the tug of the unknown, we find the pulse of discovery. And maybe, just maybe, something out there is calling us.